More and more, we are getting inquiries for people looking to switch from traditional systems like gas, oil, and propane to heat pump systems. When meeting with a client to explain how cold climate heat pumps work, I describe it as it's an air conditioner working backwards that takes the heat from the outside and uses it to warm the house. Existing furnaces are between 80 to 95% efficient, whereas a cold climate heat pump system uses 100% of the energy. For every kilowatt hour of electricity, heat pump extracts about 1.5 to 4 times that amount of heat from the outside.
Our house is a 1932 house. It has 1,800 square feet of floor space with 2 floors and a finished basement.
The first step for us was doing a home energy audit, and that's when we learned that we needed to replace some insulation and upgrade the doors and windows. We realized that space heating was our home's largest greenhouse gas emitter, and we wanted to reduce our carbon impact by reducing our home's energy load.
Some customers are worried that heat pumps can't keep up with Canadian cold winters. There's a misconception that because traditional furnaces burn hotter, that they provide better heat. Modern cold climate heat pump systems can reliably heat your home even when external temps are -28 to -29 degrees Celsius with minimal drop-off. As we look at decarbonizing and moving away from fossil fuels, we will see a lot more people turning to heat pump systems.
Our furnace was 17 years old and 17,000 BTU. It was starting to act up, and our 1.5 ton air conditioner was also getting old. As well as reducing our greenhouse gas impact, this was an opportunity to bring down our utility bills and be proactive about replacing equipment before it failed.
For this home, we chose a 2.5 ton centrally ducted system using the existing ductwork distribution system, complete with a new condensing unit and indoor air handling unit. We generally allot 2 days for the installation. Installation times will be reduced even more going forward as the systems become more mainstream. We recommend some backup heat or supplementary heat for the days that we drop below -30. In this case, we chose a 15 kilowatt electric duct heater that kicks in on the coldest of days. Clients need to remember that backup heat can add to the project costs and space requirements.
In order to meet the energy demands of the cold climate heat pump, we needed to upgrade our electrical panel from 100 to 200 amps. And we did this by working closely with our local utility company.
We knew space constraints were tough, but we had already brought the heating load down by sealing and re-insulating, so we could put in a 2.5 ton system that both fitted and met our needs.
Heat pump retrofits can be expensive, especially a cold climate air source heat pump system, and it's tough to make a decision to throw out existing equipment.
As energy costs continue to rise, the economics of a heat pump begin to make sense in an all-electric solution. In addition, incentive programs are bringing costs closer to parity.
We have an even temperature distribution throughout the home, and we found it to be really quiet, even on the nights when it's -30.
It's way more efficient. Our hydro bills have gone down in the summer.
But most importantly for us, in the first full year of operation, we've reduced our carbon dioxide emissions by 1.5 tons.
We can show cost comparisons from customers that demonstrate that hydro bills have not increased significantly.
The bottom line, home heating is one of your household's largest operating costs and a big source of greenhouse gas emissions, and a heat pump can reduce this considerably.
We suggest that you do your homework and find the right qualified contractor to do the work. A properly designed and installed cold climate air source heat pump can provide your family with years of comfort and reliability.